In this video, we're talking about the atom, and we're going to start with what's called Dalton's atomic theory. Dalton was a school teacher a couple hundred years ago who read a lot of scientific journals and realized that at one point, if you put all that together, we had enough information to come up with a comprehensive theory of the atom. And this is his theory. First part says that everything, all matter, is made up of these really small particles called atoms. Next is that all the atoms of any element are identical to each other and different from atoms of any other element. Now today we know that there can be some small or slight differences between atoms of the same element in terms of their mass, but we'll get into that in another chapter. Next, compounds, when they form, come about by atoms of two or more different atoms of different elements combining, and any compound always has the same number and types of atoms in it as any other example of that compound, no matter where you find it. For example, water. Water is H2O, meaning that there are two atoms of hydrogen and one atom of oxygen. It's that same number. It's always hydrogen and oxygen. There's always two hydrogens and one oxygen. No matter where you get that molecule of water, it's still H2O. And finally, in a chemical reaction, what happens is the atoms are rearranging. They're recombining. Maybe they're separating, but they're rearranging themselves somehow. But you can neither create nor destroy atoms in a chemical reaction. So you have, say, 6 atoms of carbon before the reaction, then you know that after the reaction happens, you still have to have 6 atoms of carbon. They might be in a different place, but they're still there. Now, we're going to talk about what an atom is made up of. It's made up of subatomic particles. There are 3 of them: the electron, and the symbol is this, E with a negative superscript, a proton, and the neutron. So we're going to take these guys one at a time. First, the way that these subatomic particles were discovered is basically because they have what's called electric charge. And so we just need to know a couple basic things about electric charge. Is that there's 2 kinds, positive and negative, and that opposites attract and likes repel, just like magnets. So you've probably all, held magnets in your hand and felt how if you put a north pole against the north pole, it pushes it apart, and if you have a north pole and a south pole, they attract each other. So these are bar magnets, and they have opposite poles, or that's or like opposite charges with electric charge. They would attract each other. So a positive electric charge and a negative electric charge would attract each other. But a negative electric charge and a negative electric charge would repel, and so would positive and positive. Now the electron, it has a mass of 9.11 times 10 to the minus 31st kilograms. Its charge is -1. The symbol is an E with a superscript negative, and it's located outside of the nucleus. So our basic picture that we're going to come up with here is that an atom has a nucleus, which is this really small, dense region in the middle of the atom. And in that nucleus, there's the proton and the electron. We'll see in a minute. The proton and the neutrons. And outside of the nucleus is the electron. And this is, by the way, a schematic of the tool that this guy named J.J. Thomson used to discover the electron, called a cathode ray tube. And this is just what was in the old TVs, the big, heavy TVs. So what you need to know from this, if you need the mass of an electron, I'll give that to you. I'm not going to ask you to memorize that. But you should know that its charge is -1 and that its symbol is this, and it's located outside of the nucleus. Now the proton is located inside of the nucleus. It has this charge, 1.673 times 10 to the minus 27 kilograms. I'm not going to ask you to memorize that, but remember that just for a minute, because I want to compare that to the electron and the neutron. Remember, the electron was 9.11 times 10 to the minus 31st kilograms. That's 4 orders of magnitude. In other words, 10,000 times less heavy than a proton. So an electron compared to a proton is really very, very light. A charge on a proton is +1. Its symbol is either just a lowercase p or a p with a superscript plus, and it's outside of the nucleus. So you should know that it's +1 charge, its symbol, and where it's located. Now, also in the nucleus is a neutron. Now, remember, the proton was 1.673 times 10 to the minus 27 kilograms. A neutron is 1.675 times 10 to the minus 27 kilograms. So They're almost the same, but not quite. A neutron is just a little bit heavier than a proton. And both a proton and a neutron are much, much heavier, about 10,000 times or so heavier than an electron. Now, a neutron doesn't have any electric charge, 0. Its symbol is N, or N with a superscript 0, and it's inside the nucleus. Now, we use a unit of mass called the atomic mass unit, or AMU. Because these numbers are so small, it's just convenient to have a different unit of mass, like the gram, the pound. Now we're going to have an AMU. And what it is, it's defined, one AMU is defined as being exactly 1/12 the mass of a carbon atom that has 6 neutrons and 6 protons in its nucleus. Now, if we were to write the mass of an electron in AMUs, it would be 0.00055 AMUs. A proton is 1.007 AMUs, and a neutron is 1.008 AMUs. So we still see the neutron is a little bit heavier than a proton, and these guys are both much heavier than an electron. It's just these are nicer numbers. So we're going to use AMUs when we're talking about things on the size, on the mass of protons, neutrons, and electrons.